Today we are discussing Docker. The Docker is a containerization tool. So in Docker we are going to discuss the topics. First is introduction to Docker, then containers virtual machines. Then we'll start with the Docker installation today, and we'll check how to install Docker in Linux server. For Ubuntu we'll take the example and we'll complete the installation part. And then architecture. So these four we are going to cover today. So first thing is Docker. So in the Docker we have Docker client, that is a CLI, where we are going to install our Docker, and we will run the commands, Docker commands, and it will go through the Docker daemon. So that is a Docker D, and then it will create a Docker image, Docker images, containers, and also from the Docker daemon itself we are going to pull or pushing the Docker images to registry, that is Docker Hub. So Docker Hub is a private registry which we anybody can access different Docker images. Even we can download them unless it is private. So let's discuss one by one. First is introduction. So the Docker is a platform that packages an application together with everything it needs to run. So for example, you need one particular application you want to develop and deploy. So for that one you are going to create it, but whatever it is required, everything we can do it in the Docker, like the application together, everything it needs to run. It can be code, runtime, system libraries, configurations, everything will be into a single portable unit called as a container. So the container which we are going to create it, it contains each and everything what particular application require. It can be operating system, memory, volumes, then each and every software is required for that application. It will inbuiltly we will get it as a libraries. The container runs the same way on developer's laptop, a teammate's machine, a test server, or in a production. So previously, before Docker, before we Dockerize the application, that is a containerization application, we were developing an application in the local laptop, for example, developer's laptop, and they are pushing the code into production. But in the production, we were facing the issues. So it is a like they were telling it was working in my system, but it is not working in the clients. So these kind of issues we are facing. That's why introduce containerization application. So before Docker, teams constantly run into the classic problem, that is it works on my machine, but differences in the operating system versions, installed libraries, configurations, this kind of it will be different will be there. That's why it won't work in the different system whichever they are trying to execute it. So that is the main reason which Docker is implemented. The main issue, it was working on my machine, but it is not working on the client machines. So differences in the operating system versions, install libraries, configuration between environments caused application to behave inconsistently. So for example, even we have seen some of the issue in the Sonar Cube or Tomcat. So the particular version, if not matching, then the application won't work. So these kind of issues we have to solve it. For that, we have we are introducing Docker. So Docker solves this by shipping the application and its entire runtime environment together as a one unit. So it's going to ship the application and its entire runtime environment together as a one unit. So as a one unit, it's going to together it will shipping the application, and it will combine as a one unit. So there will be no issues even if you change a system anywhere, any environment, we can run the application by creating a Docker containers. So why teams adopt Docker? The main reasons for adopting a Docker is consistency. The same image runs identically everywhere. So the single image which we have created, it's going to run identically everywhere. Wherever you run, it can be Windows operating system or Linux, macOS, and also it can be any systems. It will work. And speed. So containers start in seconds, not in minutes. So when you run the command Docker start, Docker build, Docker run any commands, it will start in the very quick time. It's in the seconds time only, not in minutes. Isolation. Each container has its own file system and process space. So the each container will be having the own file system we are going to create, and also the process space it will be there. There will be no issues like systems we have to increase the memory and all. Everything will be taken care by Docker. Even we maintain the Docker volumes and all with the Docker. Efficiency. Many containers can share one host operating system kernel. So we have already discussed about kernel in the Linux operating system. So many containers can share only one host OS. You can use it. That is the efficiency of the Docker. And portability. So build once, run on any machine with a Docker install. So whatever you do, even the application it is built in different system. You can download it, the code or the Docker image, and you can run it in your local machine by installing the Docker. So just a Docker installation is required, and you can work on it in any operating system, any device as well. So mainly in the Docker, we have different terms. We call it image, container, Docker file, registry, and volume. The sample. So first is image. This is very important. Even in the Docker, as a beginner also, you should know what is image, what is container. So image is a read-only template used to create containers. It is a very small unit. It is a read-only template. Nothing will be there. Just a read-only template it is, and it is used to create containers. Once you create an image, you can't do anything. Just a it is going to use to create a container. It is a blueprint of container where we can create a container by using image. Without image, we can't create a container. And a container, it is a running or stopped instance created from an image. Once we get the image, the Docker image, we are going to create a container by using Docker image. So we are going to run the command Docker build command, then we will create a Docker container. It is kind of server, same like EC2 instance. You can take it, or as virtual machines, but there is a difference. We will discuss. Next is Docker file. So file is a text file of instruction used to build an image. So to build an image, we are going to write a script that is called a Docker file. This is not any format like a text or YAML or shell script. Just a plain you have to write the file with a Docker file. That's it. It contains the complete instruction about a Docker image. So how to create a Docker image? We are going to provide the instructions to Docker. Once we execute it, it will create a Docker image based upon instructions which we have provided in the Docker file. Same like other scripting which we use, we are going to use a Docker file with a separate. These are unique commands which we use with the Docker. We are not going to use the same commands anywhere. We use only with the Docker. In the Docker files, we will be having different commands like cmd, entry find, run, install. We are going to use different commands. We'll see that. Next is registry. So registry is a place to store and share images. So where we are going to store the images, and also we can share the images in the Docker registry. So Docker registry is a kind of repository. How we have GitHub repository. This is a Docker registry where we can store only Docker images, and we can use a private and public. For publicly we can available Docker Hub is available as a Docker registry, and other than that we have like in the AWS we have ECR, Elastic Compute Registry, and in Azure we have same Azure registries. So we can use them to store images like each and every versions we will store and we can share them. Next is volume. So volume is a persistent storage that outlives a single container. So it's going to volume. We can use a persistent storage where we can increase the volumes, and the storage purpose we are going to use the container. So Docker Hub. So mainly we can use a Docker Hub. This is a Docker Hub hub.docker docker.com. So it is a Docker Hub container where we can find out any image. So for example, you want Nginx image. So you want to use. So this is a hardened image recommended. And we can use multiple images are there. So you can go here. You can find out image versions and about Docker about Nginx. Why use Docker hardened image? So if you want any other images, you can see here. So these are the Docker images which we can find out. So if you want to pull the Docker image, just command also they have provided Docker pull Nginx and the version. So that one we'll see while using the Docker command. So here you can create a Docker hub by clicking like this is just a sign up. How we create a GitHub repository, and you can create a personal account as well, work as well. So you have to provide the details and you can create it. That we'll see in the next chapter. So that is the main vocabulary, or we can call it the main terms which we use with the Docker. So once the Docker installed, example is we have to see confirm it is working by running the official test image. That is a Docker run command. You can use a Docker run and the image name is this one. Docker downloads a teeny test image and runs it inside a container. If you see a hello from Docker message, then your engine is working correctly. So once you install the Docker, then you can run this particular command. Before that, we should understand about what is container and virtual machines. So we know containers is a Docker which we use, and virtual machines is nothing but the virtual servers or EC2 instance, same kind of virtual machines we call it. So previously we were using. So VMs, virtual machines, virtualize an entire computer, including a full guest operating system on a top of a hypervisor. So it is going to use the entire computer including full guest operating system. So we are going to use a separate operating system and separate machine, virtual machine. It is a virtually we are going to use not any physical device like laptop. We are going to use a virtually same EC2 is an example. On top of a hypervisor, we are going to use it. Each VM is heavy, often several gigabytes. So if you use it, the each VM, it is a heavy size. It will be having the multiple GBs and it can take minutes to boot. So if you reboot, it will take a lot of time to reboot. Containers, on the other hand, share the host machine's OS kernel and isolate only the application layer using Linux namespaces and C groups. So this particular one, the container, it's going to use a host machine's operating system kernel, and it's going to isolate only application layer we are going to use with the Linux namespace. And also this makes the very like the containers will be lightweight. It will take very MB sizes and we are able to start in the second or two. So that is container. So when we create a container and if you want to start the container, it will take very less time to start it and we can spend very less time on the container creation or starting. So here you can see the architecture, how it looks like. Virtual machines and container both will be having the same. Here we use applications and operating system, separate operating system for each application. But here we use Docker engine with a container and then host operating system, then complete infrastructure we are going to use. So here in the virtual machines, it will be mainly we use hypervisor and guest operating system instead of Docker engine. So that's why it will be very heavy in the size, and also it will take a lot of time to start and stop. So if you compare both virtual machine and container, it will be the main features, the boot time, the time taking for virtual machines and container. So boot is nothing but we are going to reboot or restart the servers. So here virtual machines will take a lot of time, in minutes it will take, but containers very quick, in the seconds of time it's going to complete it. The typical size, so the size of the virtual machines, it will be in the GB sizes, but when it comes to container it will be very less, in the MB sizes only it will be there. On the operating system, full guest operating system for virtual machines, so it will be there full guest operating system for one particular virtual machines. But here in the containers it will shares the host operating system. So host is nothing but where you are creating, for example you are running in the Linux, Red Hat Linux, then it will share the same host OS kernel. If you are running in the Ubuntu, it will take same. Then isolation, so in the virtual machines it will be strong on the hardware level. So if you take in the virtual machines it will be very strong on the hardware level, but container it will be just a process level. So what is isolation? When comes to in the Docker, so Docker isolation, it is like running container as a scope process we are going to use that shares the host operating system kernels. So whatever the host operating system kernels, it's going to share the operating system rather than virtualizing hardware. So this one we are going to use the hardware level, but here we use just namespace and C groups as per the host OS. So C group is nothing but control groups which we can use. So C group and namespaces it will take it. Next is best for. So both are we can use both. Both are use advantages are there. But what is the best for? Virtual machine is best for running different OS types. If you want to run different OS types, then you can virtual machine is a you can consider as a best. And containers, it will be consistent, fast moving app environments. So it will be very consistent and also fast moving in the app development and deployment when we use for the app. So if you see this particular command, see how lightweight a container is compared to spinning of a virtual machine. So if you want to restart a virtual machine, it will take time, but this Alpha and Linux container starts almost instantly. So when you run this, so it's going to remove the Alpine hello from a container. So it's going to display very quick time. We are going to use Docker run complete command. It's going to execute it, and also it will throw the output like within seconds. It's going to complete it. Okay, so if you run these commands, it's going to display the word hello from a container, and it's going to show the output. So exactly the run command is instruct the Docker engine to create and start a new container. Immediately it's going to create a new container and start immediately. So what it will do, Docker run, it will instruct engine to create and start a new container. It will automatically create and start a new container, and then -rm, it will remove the container. So it is going to remove the container from the host file. Once it exits, just it's going to create it, but it's going to remove the container once it is exits. If you exit it, then it's going to remove it. So there will be no leftover disk clutter in the with the Docker. That's why we use Docker-rm and this one. So Alpine is a Linux official image. If you go here, the Docker Hub, Linux, Docker official image, you can see Linux. You can search here Linux official Docker image. So you can see here the Alpine is a default one which we use for every uh, images as a official, and it will be having the different versions. Even Alpine is a one of them. Alpine Linux is a lightweight one which we can use it, and Ubuntu, Debian, like that we can use a different one with a Docker Hub. So if you use Docker Hub, and you can search for that particular version, so particular flavor. If you want Ubuntu, then you can search for Ubuntu. You can see Docker official image, and if you scroll down, this one it will provide Docker pull Ubuntu this particular image version. So this is a version which we are going to use. This is the image name, like that. Here we have used Alpine as a Docker image, and then it's going to display hello world. So hello world is a echo, already echo command which we can use to display the particular message. We use echo. Next is Docker installation. So Docker installation, we can see Docker engine can be installed on Linux, Windows, and macOS. Any operating system we can use. But in the real time, mainly we use the Linux servers where we deploy our application. And in local also, we can get the Docker by using Docker desktop. Just you can download it and you can execute it as a exe file, and we can use it. Okay. On Linux servers, you typically install Docker engine directly. On Windows or Mac, Docker Desktop bundles the engine, CLI, and Compose together. So, running a lightweight Linux VM under the hood. So, mainly we are going to use Docker. So, mainly we are going to use a Docker Desktop in Windows, and in the Linux we can directly install the Docker engine. So, this is the Docker Desktop. I'll show you how to create. Once you create it, you can create a Docker Hub account here as well, and you can see this is the Docker Desktop. You can do more when you sign in. So if you sign in once, then you can see all the images, which one you have created, and what exactly images, a list of images you can see, and you can see the Docker Hub. If you log in, you can see here. So let me show you first installation part. To discuss Docker installation, we can install the Docker engine in the Linux, Windows, and Mac OS. So I'm going to explain it about Docker installation in the Linux. I'll create a new instance. So I'm going to create a EC2 instance, Docker, and I will use Ubuntu. So we can use Red Hat as well, but some of the features it won't support. That's why I'm using Ubuntu, and 4 GB is the minimum we have to use RAM for better performance. So I'm going to use the 4 GB memory one, and select key pair. I will use the same one. Then again, I'm going to use the existing security group which has the access of all the required ports. Then I'll take the storage as 30 GB and launch instance. So I have given the same steps here. So it will do the Docker installation. So we need instance, and then create we have to install the Docker. For that one, we have to check the OS requirements. So operating system, we can use Ubuntu or Debian based Linux or Red Hat. And then we have to add the Docker repository. Then install Docker engine. Then we have to add the user to Docker group. After that, we have to validate it. So my instance is created. This is my instance. So I will use a git bash and I will log in my EC2 instance. So first we have to do the update. So before going to install any packages for the new instance one, we have to better to update the OS by using sudo apt-get update. So in the Red Hat we use DNF. So here we use apt-get update, and install also same apt-get install. Where in the Red Hat we use sudo yum install -y, and this particular one we can use it. So kernel I am installing here. So update the package index and install prerequisite for the Docker. Then we have to add the Docker's official GPC key by using sudo install -m, providing the 7555 permission for the key rings. So no user running outdated binaries. It is not there. So if we check this particular path, whether the key is already there, we have to check it. Cat. So it is not there. Then we can run this particular command. So we can go here, Docker install steps, Ubuntu. So we can directly use the same from the official website. I'll take. So we have to install previously if there is any packages, then we have to uninstall that before going to install. So I'll run the command sudo apt remove. So there is nothing is there. That's why it is not going to delete anything. And then we have to install it. There are three options. You can install Docker engine in different ways. Docker engines, we can use the Docker desktop for Linux, or else set up and install Docker engine from the Docker apt repository, install it manually and manage upgrade manually. So we can use these three steps. I'm going to use the apt repository. So we can use sudo apt update is done. Certificate URL it is done already. So I'm going to use ipc rings. It is already done. Now sudo curl. This particular one we have to take it. So it is going to, sorry, sudo curl. Curl is nothing but we are going to download it by using curl command, the Docker Ubuntu AC, and then we have to provide the ch mode for the particular key rings. So if you check it, ls fnltr etc apr, sorry, apt key rings. Here you can see Docker AAC is there. So for the same one, I am going to provide a plus r. So read access I have provided. Previously it was read, write, read and read. So if we check it here, so same it is for all read access already there. So again it is given same. So nothing much changed. So now we have to add the repository to apt resource. So apt resource we have to add the repository by using sudo t command etc apt sources. That particular source we have to provide. Then we have to so types deb URI, this one it is taken, and suits component everything we have to given. Now again we have to update by using sudo apt update. So 47 packages can be upgraded. Run app list upgradable to see them. So that is not required. Just apt update is done. Now we have to install the Docker packages. If you want a specific version, then we can go for, and otherwise we can use the latest version. So I am using latest version. Copy sudo apt install docker ce, docker cli and plugin. So this is installing dependencies. So 7 is installed. So it is asking confirmation. It is required 380 MB. So currently I have given 30 GB storage, right? So we can go further. So it is installing. So steps I have provided here, but some of them changing. So as per the requirement, we can go to the official website here, install using repository. So we have to check the system CTL status of Docker. So Docker is running. Even if you check it, the command docker -v Docker version 29.6.1 it is installed. If you check Docker images, it will show nothing because in the Docker image we have not created any Docker images. So if you want to start the Docker, then we can run this particular command systemctl start Docker. So these commands I will update once again and I will provide you notes. You can go through it. So now to run sample one we have given here verifying the installation we can use docker version and docker run hello world. So it is going to display docker run hello. So it is pulling and extracting. So Docker took the following steps. These are the steps it is taken. If you check Docker images, now the Docker image is pulled and also Docker container should be created. If you check Docker PS, no container is not created, just a Docker image is pulled here. You can see this is the Docker image list. Now Docker is installed. The next is Docker architecture. So Docker is going to use a client server architecture. Mainly we use these are the client where we are going to run the command that is a docker client which we have installed in the linux, and it's going to run the commands and create a images and containers through the docker daemon through rest api. It's going to connect with the docker daemon and it will create a docker images and containers as per our requirement. Next we are going to pull or push the docker image into docker registries. It can be docker hub or it can be private registries like ecr and azure container registries. So these are the components which Docker client, Docker daemon, and Docker registry, then Docker objects, which we have already discussed in the previous class. You can go through my previous video. So now we'll go to the Docker hub. So Docker hub is a very important one which we should know as a Docker registry. It is a default public registry for Docker images. It hosts the official image maintained by software vendors like Nginx, MySQL, Node, Python, everything are like community images, and your own public or private repositories also you can store with a Docker Hub. So if you go to Docker Hub official website, let me show you how to create an account with a Docker Hub. So this is the Docker Hub where you can create a new account, same like GitHub. Sign in. If you have an account, you can create. Otherwise, you can either go with a continue with a Google. So I will continue with Google for now. So we can provide any mail ID which we want to use. So I will use my Tech Wonders DevOps mail ID and I will create a Docker Hub account. So once we allow, it will create. It will ask for the username. Tech Wonders. I will use sign up. So it will send a mail, the confirmation OTP. We can provide here. Verify. Verification is successful. So we are signing now. So this is the official Docker Hub account, hub.docker.com. You can download the Docker desktop application for the Windows as well and also available for Mac and Linux as well. You can download it. So here you can see any images if you want to, if you are going to push them, then you can see here and also you can search for the images. Here if you go Nginx, Docker official images. Then search for the images here and you can find out the exact version of that particular image like this. So that is how you can create a Docker Hub account. Now finding and pulling images, you can search the Docker Hub from the CLI by using Docker search Nginx. So if you search, so same like how we have searched in the Docker Hub, you can use here by using command Docker search Nginx. See name Nginx, description, official build of Nginx, and all the details about the Nginx image you can see here. So we can find out like this with the whatever the Docker image we required, and we can use it. And then we can pull the Docker image same by using the command docker pull. So Docker pull Nginx, it's going to using default tag latest. If you use the tag, then it will pull that particular tag, particular version of the Docker image. But if you don't give any tag, then it will automatically pull the version of latest one. See, this is the tag which we provide the version latest. So this is how we can create a like pull a Docker image from Docker hubs. See here, pull a specific tag or version. So if you want to pull a specific version, then we can use like this Docker pull Nginx the version which we provide here and run it. So it will pull. Now if you check Docker images, see there are two images with Nginx. One is 1.25 Alpine, one is latest version. You can also browse hub.docker.com in browser to read images, documentations, and tags, everything details we can find out in the Docker Hub. Always prefer official images. If you go here in the Docker Hub, we can find out different images as well. If you search here, see Docker image, official image, verified publisher, sponsor, everything. But always we have to prefer only official images. If you go here, you can see these are the official images. You can find out Nginx, BusyBox, Postgres. So if you want to install Postgres, then we use this Alpine, Redis, Ubuntu, Python. Even for Python also, we can use the Docker images. So everything we can find out here, and we can install as a Docker image. Then we can make it as a container. So good habits on the Docker Hub. Prefer official images or verified publisher badges. So we have to use always official images only instead of any local or public images. Always pin a specific tag or version instead of latest. So while running the Docker pull or Docker build, then we have to use particular version instead of using latest. We have to use the version. It will be very helpful. Check the Docker file source link when available to see what's inside. So Docker file source we can find out if the link is available for that particular Docker image. So sometimes a Docker link will be available. If you see here, they will provide mostly in the GitHub only. So you can see here all the details about files, and you can find out the Docker file for that particular application if they have provided. If not, no need to consider. But if it is there, then you can go through it. What exactly the particular application and what are the details about that image. Okay. Next, we are going to discuss about the basic commands of Docker. So once we know about Docker, then we have to learn the basic commands which we require, that is Docker pull. So we are going to pull the Docker image from the registry. It can be Docker, it can be our private registry. So that is Docker pull image name we are going to provide. Then Docker images we have already seen. List the images stored locally. So if you have stored locally the images, it's going to display when we run the command Docker images this. And if you run the command, for example, you want to delete. There are two images are there nginx, so I'm going to remove one of the image docker rmi image name. So now it is deleted. If you check it, Docker images. See, the latest image is deleted. Next is Docker build -t name dot. So build an image from a Docker file. If you have a Docker file, then if you want to build a Docker image, then we can use this particular command Docker build -t name. So for that one, we need all the files of our application. Then we have to write a Docker file that we'll see later. Next is Docker run image. So create and start a container. So if you want to create and start a container, then we use Docker run image is we are going to provide this one. So it is creating start worker process. So instead of this, we have to use mainly Docker run -t -it. So for interactive mode, because it will be running on the backend, Docker run -it image we have to provide. So it is not taking. Once again, I will run Docker run -it. You can give name. Container name you can provide in Unix. Then we have to provide the bash. Unable to find Nginx latest locally. Latest pulling from this one. So it is taking the latest one. Error response from daemon invalid container name. Sorry. We have to use a different one here. Nginx name. We have to provide the container name first. Then we have to provide a bin bash not found. So it is already created. If you check the PS command, it is not showing. Oh, one second. Linux demo. Okay, it is started, but it is not creating exited immediately. So I'm going to remove them first. To remove the container, we can run the command docker rm and container name. So I will provide. Docker rm. Now if I check Docker ps hyphen a. So if you use hyphen a, it will show all the containers, even it is stopped as well. If you use only Docker ps, it will show running containers. So I'm removing now by using rm. Always we use rm in the Linux as well. We use rm. Here also we use rm to delete. Docker rm. Now I will use once again Docker images, Docker create hyphen hyphen name demo container, and I will use the latest one, or else you can use hello world latest. So it is created. The container is created. If you check, it won't show. If you check ps hyphen a, it will show Docker hello world. It is already created. Now we have to use the Docker start command by using this one, and container name. Here you can see demo container. You can use the container ID as well. So Docker ps. No, not started. So it is starting but exiting due to some issue with the container itself. So we can find out what while creating a Docker containers with images. Let me pull a particular specific image from the Docker registry, or I will check here Docker image. Image to create container and run application. So we can directly run this one. So here there are multiple arguments. Let me explain. So Docker run, it's going to run, and then detach, it's going to in the run in the detached mode. If you use D, it will be in the detached mode, and then we are going to map the port number 8080 to 80. So it should be running now. See, Nginx app is running 2 seconds ago, and also it should be running fine now itself. So this particular command, it's going to map the port number 8080 on your host machine to port 880 inside the container. So if you use this particular name, it is running, and if you go into check,
A port is different now, Mohan.
port is 8080. See this one. Welcome to Nginx. So here mapping 8080 port from the default 82, it is mapping to 8080. 8080 port number for the application. When we execute it, it will run. So currently it is running fine. Like that we have to. So this is directly it is pulling the image, and also it is taking creating a new container with that particular image. So I will copy here for sample. Okay, this particular image, it will create a container and run the application in 8080 port. So this is how we are going to execute in the real time. We are going to create a Docker file that we'll discuss. So next is docker run -it image bash. So interactively with the terminal, it's going to create when we use -it. PS, it's going to list the running containers. And when we use a ps-a, it will list all the containers including stopped one. So we have checked it. When we use the docker ps, that is the difference between ps and docker ps-a. So in the real time, in the interviews also, you are going to get the question. Uh, how you are going to display all the containers including stopped, then you can use the ps-a. Only running containers, then docker ps, then docker stop containers. So currently there is a one container running, so I want to stop it. Then I can use this particular name, docker stop container name. So it will stop the container. No such container. One second. I think I have given different name. This is the name. So this is the container ID. First one is the container ID. Image name is Nginx. The container name is my app. So I'm going to, you can take the app name as well, container name as well. Docker stop. So it should be stopped now. If you check docker ps, it is not there. Even if you go here and refresh it, it won't load. See. So this is how you can stop the containers. If you use docker ps-a, it will list. Currently it is created my web app, but not running. Okay. Next, to start the container, already created container. If you want to start, then you can use the start. If you want to create a new container, then we use docker run with the image details and all. So now I am going to start again, docker start my dot web app. It is running. Same, it should load here as well, like this. So stop and start container, we use stop start, docker stop, docker start. Then rm. So to remove the container, it can be starting or it can be running. Then you can use docker rm, the container name. So I'm going to provide container name which is currently not using. Demo container I will use, demo container. So if you check ps-a, it is not running, not available. The container is removed. Next, Docker logs container. So if you want to view the container logs, then we use Docker logs container name. So this is also very important, which we regularly use to check the Docker container logs. We use Docker logs. In the interviews also, you are going to get mainly this question: how you are going to troubleshoot your issue where Docker container is not running properly. Then you can use Docker logs. You can validate the logs. So all the logs it will be fetching. So if you want to check, so the all the logs will be, you can see here, whatever the latest logs, exit, everything you can see here. If you click on this one and execute latest logs, it will be showing. So Chrome, it is using what is that code we are getting, everything it will be show. So for that one we use docker logs command with a container and ex-it. So these are also very important, where we go inside the container and there only we are going to check the logs, not with a normal Linux system. We are going to check inside the container. For that one we use docker ex-it container and bash. So if you see here, docker exec. So this command you should remember. Other than that, -it is normally iterative mode where we are going to use, and then container my web app. So I have used, I think, bin bash. See, Now it is inside the container, where previously it was there in the IP system, IP address it was showing for my Linux. Now it is showing container ID. So I am in container ID now. You can see all the details. If you give ls, it will display the all the container details like bin, dev, everything, and also logs we can see here. And if you want to create any files inside that one, you can create chat touch hello. See, this one I have created. So this is inside the container, and also if you want to change any changes, then we are going to do the changes as well. And we to check the logs, we can go inside logs here. Cd var, inside var it is log. You can see here backup log, nginx, all the details you can find out. So in the real time also we'll be having different files. See access log and error log. If you have any access log issue, then you can check it. Access log, currently there is no data inside because there is no issues regarding cat access or error logs. So these are mainly we are going to check inside to we are going to log into the inside container to check anything if required on the log side. And mainly we have to remember this particular command. What is the command to log in inside the container? Then we use docker exec hyphen it container name, and you can provide the shell. So to run an interactive Ubuntu container, then you can use docker run hyphen it Ubuntu bash. So this is the same which we have used for nginx. I have used. You can use this one. Again, once again I will run for the Ubuntu container. So exiting from the container, you can use exit. So now I'm in my Linux machine. Docker and hyphen it Ubuntu bash. So Ubuntu latest locally unable to find. So it is pulling directly from the Docker hub. So when you run the command, it's going to pull it and it will go inside already. Docker run hyphen it, and we are already inside the container. You can see here. So when we use a Docker run, it will create a container and it will start, and we go inside the container. And the here we can see same as Ubuntu how we use the Linux machine, how I am using now another one, same like we can find out inside. So we have already discussed in the Linux class, right? So if you want to check etc pass, you can see here, and all the same like virtual machines we have created as a container. And here you can create whatever you required, you can install it, and you can use the Docker container as a Linux machine. So for example, I want to add the user. Now if we check cat etc pass wd, see here move on. So these are user new Linux machine created Ubuntu machine as a Docker container. If you check Docker ps, currently Docker it is stopped. I have created only by using run command. It is created, and once we exit, it's going to terminate it. See here, Ubuntu exited 15 seconds ago. If you want to start again, Docker start. This one you can use. And if I check Docker PS, see Ubuntu started. And if I want to go inside that one, that is same exec hyphen it container ID or container name you can give. See, now it is a inside. So bash we have to provide because we have to use which shell we are using. Using that one here created. While creating itself, I have mentioned as a bash. So we have to provide. Like that we can go inside and same exit. Now if I check Docker PS, it will be still running. Just I have exited because I started it and then I logged inside that one. Docker stop. So in the real time, we should not stop the Docker containers because it will be running the application where we can't stop anything until unless there is a maintenance window and we are doing some maintenance activity which makes application down at the time. Okay. Now Docker run -d -hyphen name web server. So same above I have already executed, but here I have mentioned same command. You can see here, right? Same command I have executed for Nginx. Docker run -d. We have provided all the details. It will run the container as a web server name and it will use a Nginx as a image. We can use the same to check the logs and all. Inside the running container, if you want to open a shell, then you can go inside that one and you can use the Nginx HTML. So for example, this particular content where exactly it is there, if you want to change anything, if you want to make the changes, then you can go here, docker exec hyphen it bash. So I am inside that one and I can see the file path here, user share Nginx. So if you go cat cd user share Nginx, here you can see HTML open, vim is not available, HTML, okay, it is not opening, nano HTML, nothing is there. So we are unable to open that file, just we can see the content. Let's see cat HTML. Oh, sorry, 1 second. First of all, I want to check. HTML is a directory, that's why. So cd HTML. So there are index.html and 50x.html. So I can go inside index command not found. Cat index.html. You can see this is the one. It is available for online documentation. These details it is there. So to edit that one, we have to install the Nano first. So Nano is installed, not installed. Let me check. So Nano is installing. For now, it is not available. That's why I'm using Nano index.html. You can see here. One second. Control C. So I'm going to change the content just for updating purpose. I will use wonders. Now I will use Now let's see if it is updated or not. Index.html. Yeah, it is updated. Now I will go back once again. So if I refresh this one, see, welcome to Taekwondo's DevOps Docker class. So it is updated. So inside the HTML file, whatever the changes required, then we can update it. But in the real time, we are going to use a mainly Docker CP command instead of that one where we are going to use. So this particular content I will copy once again. Currently, this content is available inside the container. So I will use this one. I will create a new file index.html. So if you want to copy a file from your Linux machine to your Docker container, index.html, copy, exit from here, and no, why it is not copying here? Okay, it is not working. The copy paste is not working. It's okay. Fine. So normally to copy a particular file from our Linux machine to Docker inside the Docker container, then we use then we are going to use a Docker CP command. So that's what I want to show, but here the copy paste is not working. That's why I couldn't then. So we can use a Docker CP, and inside the container we can use a container details. Then it will directly copy inside the container. So the command should be like this: Docker CP. Then we are going to provide the index.html path, wherever we are going to use that index.html path. Then we have to provide a container name, then path. So whatever the path where we want to display that file. So for example, here it is USR, here this one USR share nginx, share nginx HTML. Then we have to provide index.html. Like that we can provide. So Docker CP command mainly used to copy content from the Linux to inside the Docker container we use. So that's it about Docker's image, basic commands about image and Docker containers. Next is we are going to create a sample Docker image with the help of Docker container. So this is very important, where we are going to write a Docker file. Inside a Docker file, we have to use multiple commands and to run our application. Dockerfile describes step by step how to build an image. Running Docker build turns those instructions into an image. So Docker run, then start a container from it. So first when we use a Docker run, it's going to create a container. First is Docker file. We have to write a Docker file. Then we use a Docker build to build a image. From the image, we are going to run the command Docker run to create a container. So here the basic Node.js application. It is a web application where we can create an application with this one, and this is a Docker file. We can write it. So let me create one application. So I will create a directory first. Make directory Docker demo. Here I am going to create a app.js first. Vi. So this is the content. I will copy. Oh, why copy is not working at all? Okay, it is not working at all. Const http. If I try here, it is working fine, but inside that one, it is not working. Once again, keys. So you can set the selections here, keys, mouse. Yeah, it is pasting here as well. VI CD Docker demo. So let's open app.js. So I'll use different echo and I will add the content by using echo only instead of that. It is not working. So I will copy this content in my application. So I'm going to use here copy echo app.js. Now if I check app.js, it should be present the content. Okay. Now same I'm going to use for package .json. Okay. This is the package.json file where we are going to use vi package echo package.json index.html. Okay. Both the files created now. Oh, sorry. I given index.html. This should be package.json. So I have changed the file name with the mv command. Package.json created and app.js file created. Now, very important Docker file. So this particular Docker file which we are going to create echo. So I'm going to explain you what is exactly and I will create a image Docker file. So these are the three files which we have created. So Docker file should be just it should be a Docker file. There should not be any extension like .txt, .html. This is a empty Docker file without any extension, and we are going to inside Docker file. We are going to write these commands. From is the first command in every Docker file which we use, and it's going to use a base image where we are going to use a base image from which one we are going to pull that image, and we are going to provide the details about a Docker image. Next is copy copy command and then work directory command. So work directory command which we are going to use mainly for the creation, like where we have to provide the work directory, complete work directory of the software, this particular application. We are going to provide the details. and then we are going to copy the package.json to the particular path. So the particular path is we are going to provide. Here I have given as a dot, and wherever I am going to execute it, it's going to copy that into that particular path. So these are the main first three commands which we use in the every Docker file. So from node 18 alpha, so it's going to official node.js version from the base. So if you go here, where is my Docker hub? This is the one. So if you check here, node Docker official image. So this is the Docker hub. In the Docker hub, you can find out the node official Docker image. But this is a node trick we have used instead of Alpine. So Alpine mainly we are going to use for the to make the very small size of the application. So you can see here Alpine support tags and respective Docker file links. If you want to find out Docker file, that particular 18 one, I am looking here 18 Alpine. So you can see 23, 18 alpine, 18 alpine, all the details you can find out. And for that particular version, Docker file is also available. So these are versions on Docker file. You can see inside the Docker file, they are provided from Alpine 3.23. So they are using again base for the Alpine 3.23, and env they have provided like environment variables, and then it is completely for that particular application, particular image they have used a Docker file. So here we have used a 18 alpha as a base image for the node version, node Docker image 18 alpha. So this is the 18 alpha one, and if you want to use the latest one, then you can use Docker this one node Trixie. So this one also we can use it if you want to change that particular image from where we want to get that application. Mainly the Alpine where we are going to use for the reason is lightweight. The Linux distribution it's going to use as a lightweight. That's why we use Alpine. This is also very important. In the interviews you will get the question. You want to make your Docker image as a very lightweight. Then we can use the Alpine as a base image. Then is work directory. So work directory slash app is it's going to create and sets the app directory as a working directory inside container. So when you go to the inside container, it's going to create a slash app as a home directory as a working directory inside the container. So all the commands which we are going to run, it's going to run inside the app container only. And inside that one, it's going to copy package.json. So package.json I have given as a dot. So why I have given as a dot? It's going to copy to the this particular one. We are running the command from app. So it will run to the app only when we give dot. And so it's going to copy the package.json to that particular folder local wherever we have written, right, local file package.json file. It's going to copy to the containers current directory, that is a same slash app. When we use a dot, it's going to copy to the current directory. Here I have mentioned working directory as a slash app, that's why it's going to copy into that particular app directory. Next is npm install. So why npm install is required? So it's going to we are running node application. For node we have to use the npm. We have to install the npm. That is required for the node.js application. Here npm install command run npm install is execute the package installer to download all the dependencies. So it's going to download all the dependencies listed on the package.json. So if you open package.json here, whatever the requirement dependency is added, it's going to download the packages for that one and it will make it available. Next is copy dot dot. So it's going to copies the rest of the local projects whatever the rest of the project, except package.json, all the required files, like except all the files means there is only two files, app.js and package.json. So package.json is already copied. Now it's going to app.js JS file. It's going to copy to the containers working directory. So working directory is same app. Then it's going to expose the 3000. So it's going to inform the Docker that container listens on the network port, that is the 3000 at runtime. So for example, you are running any Tomcat or any other applications, then we can give that is 8000, whatever the required port we required. And next is CMD npm start. So npm start is different, that is for Node.js commands. And here CMD we have used defines the default command that runs automatically when the container starts. So when inside the container it's going to start, it should automatically run this particular command. So for example, once you start the container, the default command what we want to execute, that one we are going to provide in the CMD. So in Docker file we have different commands. One is CMD, another one is entry point. CMD we are going to set the default arguments when the container is created. What are the commands we want to execute, those we are going to mention with the CMD. But when we write the entry point, we can override them, like we can change the those particular commands inside the container once we log in. But this one is default arguments which we have set up with the CMD. This is going to launch the web application. Once we are done with the CMD, it's going to set up the web application. Now I'm going to save it. So I have not written any changes. So I'm going to exit it. So now Docker file is written and a JSON file app.js is done. Now what we have to do, docker build -it first image.com. So it's going to, we can provide the not only first image, we can give any image, the name we can provide. So it's going to build the Docker image. So what I'm going to do is docker build -it. I will take -it and the name I'm going to provide Node.js demo. As a image name I will provide, and a version we can take 1.0 as we are doing first. So this one we can use. So this particular command, docker build command, we have to execute where the docker file is existed. If you run in any other path, then you have to provide this particular, instead of dot, you have to provide that particular path, then it will work, otherwise it won't work. Okay, shortened flag I in IT. So I is not required. Docker docker build -t. So it is going to run it. So total 9. Error, run npm install, warning found, use dogger debug to expand. So it is throwing error, failed to build. So it is not, npm installation is not done. That's why it is throwing error here itself. So what is the exact error? We have to check it now. Docker images. If you check here, image is not created. It is throwing error as npm install is not running. Let me validate it. So we have to run the npm install inside the local itself first. Npm, first we have to install it in the local. Npm install is not found. So I have not installed npm. Node.js install Ubuntu. So we have to use this one curl command. So npm install is done now. So node is installed. Npm-v installed. Now again I will run the docker build command. Still facing same issue. Did not completely successful. So I'm going to use npm hyphen v node hyphen v 26.4.0. So I will go inside Dockerfile. So it is again taking because I have given the different version. No, again it is failing. Let me check it. So these kind of issues we normally face, we have to troubleshoot them and fix. So common quick fixes: match node version from the node, match node version we use locally. So currently I'm using node-v 26.4. Same I have used in the Docker file. pm install, even it is not working in locally. Complete log of this run found. Vim Docker file. Okay, not working. Let me check. Current file itself wrong. It is showing. Okay. Vim. Okay, it is completely wrong. That's why it is throwing error. So complete double quotes are missing here. I can see package.json version and all. So it should be like this. The value should be in the within double quotes. So while doing copy paste, these mistakes we have to check it once again. Then only it will work. Start. So if I save it now and try to run npm install, see now it is up to date. Now if I do same in the Docker file, I'll do install. So I'll run docker build -t images. See, Node.js image is created. It is throwing a warning, but it is created a Docker image, whatever we have created just now. If you check it, so the image size is too much now. If you check where Docker images, so currently 1.78 GB the image size. Let me change the Docker build, sorry, Docker file. I will change it once again. So I'll use a version. Let me see if it work or not. Once again, I will go to node and I will use the same 18-alpine 18-alpine and I will rerun docker build. It will throw error. No, let's hyphen here. Docker images. See, now this image size is 1.0. It is updated. I have not given any different version. Previously, it was a 1.5 GB something. Now it is changed to 1.81 MB because I have given as a Alpine lightweight. That is the main reason to use Alpine as a base image in any Docker files. This is very important, which you are going to get the question because we have to maintain the lower size of the Docker image, our image. Then how to maintain that? Then you can mention the base image. We can use a version of Alpine from the official Docker official images. Then it will be low size. Now I have created a Docker image. So by using the Docker image, we can create a container as well. So I have executed this one to build the Docker image. Now next is Docker run. To run a container, we are going to use the command Docker run. So let me execute. So for that one, Docker run -d-p 3000 is a port which we have mentioned to expose. And next, my first tab, you can give any name for that one. And image name should be whatever we have given here. So node.js demo hyphen colon 1.0. So I'll use same node.js. Okay, now I execute it. It is created docker ps. No, it is not created. Docker ps hyphen a. It is created but immediately exited. You can see here docker log container docker logs. So npm not found. We are getting the error. Npm not found. It should be the npm not found command is maybe inside while running docker container. So docker file we have to update it. It is showing npm start. So we have to go inside again docker file again. Here also same. The double quote is not added. So I have to add. So in the notes it is fine, but while doing copy paste, these double quotes are missed. That's why we have to make sure while doing copy paste we should check it. Here also it is there properly, but copying to Linux machine, it is missed. Now if I check Docker file, okay, fine. Now what I will do, I will run again because the image should be updated. So we have to run the command docker build. So now I'm going to use the version 2.0 instead of 1.0. So it's going to create a new image. And if I check docker images, see 2.0, same size, but the version has changed. That's why it is created new image. Now I'm going to run Node.js 2.0. 1.0 is throwing error. Now I'm going to use 2.0. But before that, we have to delete the container which is already existed. Otherwise, if you run the same command, it will throw the error. Let me show you that. I want to show you more errors because it's going to useful in the real time. So here you can see if you run the command docker build docker run command to create a container with the same name which is already existing, it will throw this kind of error. Error response from daemon conflict. The container name my first app is already in use by container. So what we have to do, it is already mentioned. You have to remove or rename that container to be able to reuse that name. So now I am going to use, I don't want to that particular container. So I will delete it. This one I will delete docker rm. Now if I check docker ps-a, it is not there. Now again I'm going back to docker run command and I will execute it. It will created a docker container. If you check, see now it is running fine. Docker Node.js demo 4 seconds ago. If you check docker logs, see listening on 3000 port, first image, everything it is showing. Now what we have to check, we have to go here, copy our IP address wherever you have created, same one you have to copy and check for the 3000 port. But it won't work. Why? Any of you? I think we already know about this one, the issue. Rakshita, no need to hesitate. You can answer if you
Sir,
don't. This one is still not loading. The container is running fine, but still that is not loading. Any reason why? I think we have already discussed in the Linux class, Linux Tomcat. Many times we have discussed. Dilip,
Yeah, Mohan. Yeah, Mohan.
yeah, this one is not running. The container is
version changes.
no. It is not regarding Docker. It should be regarding the Linux
Oh,
AWS. This one is application is running fine backend, but here in
okay.
the browser it is not loading. Why?
Port, Mohan.
Yeah, so port is in the security group we have to enable, right?
Yeah.
So in the if you go here,
Inbounds, outbounds.
yeah. So in the security group, where which security group is attached, in that one inbound rules you have to update. We have already discussed same in the Sonar Cube. We have given and we have
Okay.
given for the Tomcat 8080. Now same I'm going to add rule 3000 port. Anywhere I will take for now, but in the real time we have to use that particular IP address which we want to provide the access. We will give. See, hello from my first Docker image. This is the content just we have created. If you check the file, this is the content which we have done in these files. See, this is the response we have added. So same if you want to update it, then you can do same. For example, you will get in the real time. So once you deploy, not that is not enough. What we have to do? We have again and again we will get the different versions of code. So at the time we will pull the code and what are the changes they have done. We will run the Docker build command. So what changes they are going to do? So this particular file, which one app.js. So this file I'm going to change it again. Welcome to Tech Wonders Docker images. So now I have updated the changes. Now again, what we have to do? We have to again create a Docker image with the same Docker file. So for that one, again we have to run the Docker build command. So Docker build -t. So I'm going to use the version 3 here. So this is kind of versions we are going to change. Whenever the code is updated, in the real time we are going to use the version changes mainly for the major changes. If there is any major changes happen, then only we will use the versionings. Otherwise, we will use the same version. So now, if you check Docker images, Docker image 3.0 is created. Now what I will do, Docker. So I will use that particular container still I want to be running. Again, I will use another one here as app2. I will use and I will use for the 3 as a Docker run. Okay, it is failing. Error response from the daemon failed to set a container networking. Okay, why it is failing? You can see right the error.
Port is already allocated.
Yeah, port is already allocated. That's why
You need to
it
change the port
is
or you need to
no.
move.
The Node.js application is already running. So it is already the port is already running, right? That's why it is taking. So let me change it to different port in the Docker file. Okay, here what I will do 3001.
And in AWS also you need to change, right?
Sorry, which one?
In AWS also.
Yeah, that one will change. Now I'm again building the Docker image to same version 3.0 only, and I will run this one. Okay, you have to remove. Okay, the container is also off baked. That's why what we have to do. It will be in the stopped state, so we have to delete it. Where exactly my first app to this one. So this one I'm going to Docker rm. So even while creating a Docker container, if it is failed in between, that half-baked kind of Docker container will be running in the backend. Like it will be in the failed state, not running. So we have to make sure to delete it before creating a new container. So if you check with the Docker ps-a, it will show even if it is in the stopped state. Okay, port is already allocated. 1 second. What changes? Docker ps-a. I'll delete the first this one Docker rm. Now I will do vim Dockerfile 3001 expose I have given here. Not only Docker file, we have to change it here as well. So it is created. If you check, see this particular one, 301, 3001, it is done. Now I will go. I will run here 3001. It won't work. So we have to edit the inbound rules once again. And I will use something which is already 9000. Save rules. Till it is not running. Okay, I'll go back, edit. In API, save rules. There was error modifying the security group inbound rules. Already exist. Okay. Then why it is not going? It will take time. So everything we have updated. Docker PS. So 3001. That is fine. Docker logs. Let me take container ID. Docker logs. Listening on 3000. Why? This is the issue. Let me check. So I'll check all the files once again. App.js. Okay. Console log listening on 3000 only it is updated. Vim server listen 3001. So this is just a displaying log only. I am changing, not everything. And Vim package.json. Sorry, package.json. This is fine. Vim Dockerfile 3001. This is also fine. Docker build we have to run once again. Now Docker images 4.0 Docker Docker stop. I will stop the container. This one, my app, first app 2 now. So I can create a new container with the same name. So I will use a version 4. Okay, we have to remove it. So let me remove Docker RM. Yeah, now it is created. Docker PS 4.2301 Docker logs. So listening on 3001. Yeah, see, now it is working fine. So when you use this one, this is I am using 3000. It is running in the 3000 port. Same it is using in the 3001 port. So main task which we are going to do in the real time, we are going to get the source code, everything from the development team side only. So if you check, this is the sample source code. These three, four. In this one, this is automatically generated as a package log JSON and package JSON, app.js. These kind of files you are going to get from the development team side, and you have to write a Docker file for your code to build a new Docker image. This is how we are going to write a Docker file to create a new Docker image. Okay, so Docker catches each instruction as a layer because we copy package.json and then we are going to run the install before copying the rest of the code. So before going to copy the rest of the code, it's going to execute the particular one and we are going to update all the required details. So here we have created a Docker image and we have written a Docker file and created Docker image, building everything is done. So every time, whenever we write the Docker files, we are not going to create a Docker container. We create it, but before going to that, we use the particular images we have to store in the Docker registry as well. We have already discussed where we have discussed this one, the architecture. So it's going to run the Docker file, this one, Docker architecture. We are going to run the commands. Then in between Docker daemon will be create a containers, images, everything. And then also pull or push into Docker registry. So pulling is already we have done with the command Docker pull, the Nginx command which we use, even whatever the versions which we use. But how to push the Docker image? So now I have created multiple Docker images for my application. This particular application, Docker image version 4.0, I want to push. So what is the command? So Docker push, we have to use the Docker push command.
Dot.
No, not that. So we have to provide complete
Containerization.
Docker Hub details. So Docker Hub, we have to where we are going to push the Docker image into Docker registry. That is a Docker Hub. So for that one, we have to use before going to push, we have to log into the Docker registry. So otherwise, where you are going to push it. So it will check using web-based login. Your one-time device confirmation is this one. What exactly we have to do is, please enter to open your browser or submit your device code here. So we can go here. Otherwise, you can just enter it. You can go here, activate login Docker, your one-time code. So same one-time code is this one. So once we copy it, congratulations, you are all set. So currently I'm in login, right? Where my Docker hub, this one. That's why it is asking. Otherwise, it will ask for the login credential as well. Now Docker login is done. Now what we have to do is we have to the particular tag we have to provide to the Docker image. Otherwise, you can directly use Docker push Docker hub username. So what is my username? So you can go here. You have to create this one. Please create today. It will be helpful to practice. You can go here. This is the my username. tech wonders slash repository name. So where it's not going to directly deploy into the Docker Hub, we have to create a repository. Here you can see repositories, hardened image collaboration and all. So create a new repository, repository name Node.js demo. So Node.js application images. So this, for example, even in the real time you are working, so you are going to provide the particular repository name. So where, if you see here, this is the repository name, Maven Enterprise Application. So whatever the repository name which we are using in the Linux, sorry, GitHub, same repository name we are going to use in the Docker Hub. So in the Docker Hub also we provide same name, the project name, then we can use the to push and pull whatever the images in the private. So if you keep it public, anybody can access. If you keep it as a private, only visible to you. Like this, you can create it. So if you see here, tags, pushed images appear here. And now I will go back to this one. Tech wonders. Repo name I have to provide. So repo name is same. This one you can directly copy it. I have already given. Same, you can remove. Docker push. This is very important. You should know about this one. So it will be username slash repository name and then tag. So which tag you want to add it? 4.0. So the push repository to repository Docker tag does not exist. So tag is not available. You can go here. So tag is not created. We have to create a new tag, the particular image. For that one, we have to use a Docker tag. So image name. So what is the image name? This is my image name. I want to take it. Then we have to provide the complete username and repository slash tag. So I'm going to create as a 1.0 now. Otherwise 1 I will give. Invalid repository form. It is not taking. Okay, it is created. Previously it is 4.0 was there. Actually that was not correct one. I have copied from here, right? Completely I have copied. 4.0 is the version I have used previously. Now I have created as a tag 1. Tag 1 is a tag which I want to replicate in the Docker Hub. So for that one I have created. Now I have to use tag 1 here instead of 4.0. Now if I go here and check it, still not available. So Docker, okay, Docker tag I have used multiple times. Now I have to use a command Docker push wonders demo and the tag 1. See, the push repos to this one, it is pushing. Same like GitHub, how we do git commit and git push. Here also we use Docker push. Docker login and Docker push. Tag 1, it is done. So if you check here, See, the tag one is done. You can update the name as per requirement. In the real time 1.0, 2.0 we are going to use. See, image layers, all the details you can see here. What and all it is included. 301, 3001, CMD node, work directory, entry point, Docker entry point, sh. So everything we can find out here. So this is how we can push the code into Docker container. So now I want to do different one instead of 4.0. Previously another one also we have used, right, 2.0. So for that one, Docker tag. So I am going to use a v1.0 as a tag. So now same, I am going to run v1.0. So it's going to push a new one. The layers already exist, that's why it won't take much time. Now if you check the tags by refreshing it, see v1.0, this one it is created. So it's going to push the code to push the images to Docker registries. From here we are going to take and deployable. We are going to make it as a deploying to the application servers. So that one we'll see in the different classes, not in Docker. So the Docker work will be creating a Docker image, Docker container, then pushing in Docker image into Docker registries. This is the Docker mainly we use the architecture. So that is about how we can create a new Docker image, and using Docker image you can create a container and deployable the application. That is completely we can do it, and then we are going to push the Docker image into Docker registries. So we have discussed Docker image, Docker file. Yeah. So today what and all we have discussed, mainly we have discussed about Docker file creation. If you come here, Docker hub is done today. Basic commands done. Create first image is done. So installation. So these four is completed today. And in the next class tomorrow we are going to discuss about working with multiple images. I think we have already discussed today as well. Tomorrow I will start with working with multiple images and packaging a customized container and container commands with a Docker. So different one we are going to discuss tomorrow. That's it for today. Thank you.